where'd you go? Thank you. As Rob said, I work for Deseret Book. I'm one of their senior software engineers. If I start talking too fast, just say whoa. There we go. But yeah, I've done a couple projects for Deseret Book. A lot of them include working with Solidus as well. For instance, I've worked on a project where we've had to integrate with a third-party warehouse management system. That one, it was pretty challenging for various reasons, as well as creating custom payment methods such as gift cards, stuff like that. Today, though, I want to talk about kind of how we deploy and how we take our project from development to production, just as it says. This project was originally very, very technical. I've tried to abstract a lot of that, and I've placed it into 3 different articles. There's still a few things I need to add and update there, but for the most part, you should find it there if you want to look at the kind of more technicalities of stuff. However, keep in mind this presentation is going to be fairly technical, so I apologize to those who aren't technical here. Buckle up. Yeah, and I'd also like to kind of focus more. This presentation is going to be focused a lot on deployment as well, which is very opinionated, and what I mean by that is there's many ways to do it, and so I'm not saying this is the way you guys should do this. This is just the way we do it at Deseret Book, and I'm going to kind of explain why we do it that way and how it's helped us. So what we will be covering is we're going to talk about CI tools, and we're going to be talking a bit about Docker as well as Amazon Web Services. I guess by a raise of hands, is anyone here familiar with Docker? Oh, perfect. Same raised amount of hands, has anyone written Docker files? Okay, this will be excellent. Perfect. So first, I do want to talk about continuous integration. For those who don't know what continuous integration is, essentially it is, by strict definition, it is when developers are pushing to a common branch frequently. So some define this to be at least once a day. By an unstrict definition, what we do at Deseret Book is every time we push to our repository, we are going to take that code and we're going to build it, and then we're going to test that code, and then if we see fit, we're going to deploy that code. So that's kind of the difference really between continuous integration and continuous delivery, is that continuous delivery, not only are you building and testing, but you're also going to ship it automatically without really any approval. You're trusting in your tests for the most part. These are some of the tools that are out there. The more popular ones, I guess I should say. We will be speaking, or I will be speaking more on GitLab because that's what we use at Deseret Book. However, the things I do discuss are going to transfer over fairly easy. The tools are usually pretty similar. So there's Travis CI and there's Circle CI. Circle CI is what Solidus uses to test their code. And there's CodeShip as well. So at Deseret Book, this is kind of a bird's eye view for our development lifecycle. We code, and then we push our code. That code goes to our CI tool, and that CI tool will build, test, and deploy, and our deployment goes to a tool called Elastic Beanstalk. It's an Amazon Web Service, and I'll go into that a little bit later. The nice thing about this is our first kind of implementation with this was fairly similar. However, our build, test, deploy was all in one process. So we had a lot of issues where a deployment would fail, and then we had to retry the entire process. So we had to rebuild, retest, and then deploy, even though the only thing that failed was deployment. So one of the better things we've done is we've separated that out. This is a real example from one of our projects. Essentially, we have 4 stages, is what GitLab refers to them as. There's build, test, release, deploy. And underneath each of those stages are jobs, and these jobs run in parallel on each stage. So when one of these jobs fails, it will discontinue. It will not continue down the pipeline, so you can be safe that you fail fast. Essentially, what this is doing is we're building a Docker image, we're testing and linting, and then we are going to upload our code to S3, which then gets deployed to Elastic Beanstalk. Bird's eye view of what Elastic Beanstalk looks like for us is we have an application load balancer. This load balancer sits in front of one or more EC2 instances, and it's backed by Postgres database. The nice thing about this as well is our EC2 instance, as traffic increases, we can scale up, which is nice for the holidays. If we look closer at the EC2 instances, we actually have multiple Docker containers running on each instance. So we have a Docker image, which is our Rails application. And then we have an Nginx image, which is our web server. So, kind of to summarize all this, I want to talk about why we as Deseret Book are loving our CI tools. And the biggest thing is we can focus more on coding and producing features rather than focusing on DevOps. If you ask anyone here from Deseret Book whether they are a DevOps person, they will all tell you no. So the nice thing about our tools is we've only had to code it once, and then we can just use it without hardly ever touching it. It also has increased our code quality. So anytime we review something, there have been tests, there's been linted code, and we can look at that and see, okay, everything's passing. It makes code reviews much easier. And this also allows us to merge with less stress, knowing that there is test coverage and the linting has been done. However, there are some cases where bugs do sneak into our code, but because we push frequently, it's very easy to look back and say, okay, this is attributed to this merge request right here. And so we can go in and more easily look at our code. And I don't know if anyone here has ever not had the practice of pushing frequently to their repository, but if you've ever had a conflict which spans hundreds of files, then I think you know why this is nice. So, what are Docker containers? For those who don't or haven't worked with Docker, a Docker container is essentially packaged software. So I like to think of it as IKEA. When you go to IKEA, you're going to build out a living room, for instance. So if you want to build out your living room, you're going to purchase a couch, and then you're going to get a table, and you might get some artwork, some pictures. This is essentially what Docker is, where when you want to go and build, for instance, a web service, you can go in, you can get your web server, which could be Nginx or Apache, and you can grab your application for your code. So that might be a Java image or Python or whatever, and then you can also grab a database as well, which could be Postgres, MySQL, SQL Server. So that's how I like to think of Docker. All these images will live in what's called a Docker registry. I like to think of this as kind of like a Git repo for Docker images. So when you push a new image, it gets versioned and it's in the cloud. Just some terms I wanted to define before I continue is host. In Docker, the host is usually it is your operating system. So this could be your laptop that's running Mac OS, Linux, could be Windows, whatever your operating system is where Docker's installed. And then you have the notion of Docker volumes. This can be confusing to those who are kind of new with Docker. It took me a while to kind of wrap my head around it. Essentially, it's a little bit like a symbolic link. You can choose a file directory to create a volume out of, and you can mount that onto a container to share that file or that directory with the container from the host. So, to kind of summarize, and I'm a visual learner myself, so I like to have some visual aids. You have a host. This is your operating system, and that host runs a container. So something important to know about this container is it is isolated. So by default, a container is not going to be able to reach out to your operating system or your host and wreak havoc on files, or maybe some malware snuck in or something. It's going to be very difficult. So that container is isolated, but you can mount volumes. So for instance, on this host, we have a volume for var/log, and it gets mounted onto the container at app/log. You can, of course, choose and configure that. But essentially what happens is if the host adds a file to that directory, you'll be able to see it on the container, and vice versa. If you add a file in the container, you'll be able to see that file in the host as well. So this can be very valuable, especially if you are shipping logs. You can mount a directory on that shipper so it can just collect those logs for you. So you can also bind to ports. So by default, again, containers are isolated. You can expose ports, and you can bind to it on the host. So in this example, what's happening is I'm binding to the container port 3000 to port 80 on the host. So if I were to run Rails on the container with this set up, I could go to my browser at localhost, and it would pass that on to the container, which is my Rails app, and serve that code. So why does Desert Book use Docker? I don't know if anyone else has had this experience, but there have been projects where what I do is I SSH onto the server, I log into the server, and I do a git pull, and it's sometimes a bundle install or bundle update, or I'll do a sudo apt-get upgrade, and this is very dangerous. Also, when you are keeping track of your libraries like this, I like to call it tech rot. Some people call it tech drift. But you lose track of what libraries are installed on your operating system and what's there, and sometimes versions get out of control. And there's times where you don't really know how to repeat the process of redeployment because it's already set there and you forget. This can be bad when the server goes down. It can take a while to kind of figure out how you bring it back up. It's very easily broken. So I use the help of the internet to come up with some memes as to kind of emphasize my point of why Docker has been great for us. I don't know if I mentioned this earlier, but because Docker runs on most operating systems, you can essentially take that same image and run it anywhere. So let's say I was using a Windows server before. I can then take that Docker image and I can put it up on a Linux server without any troubles. It will transfer, and vice versa. If I have something running on Linux, I can move it over to Windows as long as it's running Docker. Works on my machine. I think we've all heard that one before. I've said this one quite a bit. And my favorite is to sum up Docker is we'll ship your machine then. And that's essentially what Docker is. You are creating a fresh environment and you are shipping that to production. So at Deseret Book, we have a stage cluster and then we have our production cluster. So our stage cluster is actually the same exact thing as what our production will be, and this allows us to really understand what and kind of imitate what it's going to be on production in a reliable way. So how do we containerize our Rails applications? I'm not going to go into too much specifics on this, but this is an example Dockerfile. It's very basic. And the Dockerfile is really what it tells Docker how to build your image. Essentially, this will sit in the root of your project usually. And this, I'll go through kind of step by step, just give a summary so you know what's going on here. What we're doing is we're borrowing from a Ruby image when we have that from statement. So we're saying, I want to use the Ruby image. This makes it so we don't need to go in and install Ruby ourselves. We want to keep things dry, and we don't want to reinvent the wheel. I then copy my application code into a directory called /app. You can call that whatever you want. I just chose /app. And then I run some commands here. These are just pretty much installing Node.js and Yarn, which is usually required by later Rails versions. You also see I have build essential right here. If you want to get real technical, I can actually go into this afterwards. Probably not a good thing, but it is required to build certain gems. So Ruby is built on top of C, and some gems need C compilers in order to build themselves. So I do need that build essential statement there. And then of course, I just install all the dependencies I need from Yarn and Bundler and precompile my assets. I make sure port 3000 is accessible and can be bound to, and then I run this command bundle exec puma-c config/puma.rb. So this command just sets the default command when you run the image. It is going to start your Puma app server. If you don't know what Puma is, it comes with most later Rails version, or all kind of late Rails versions. It is your application server. Its job is to pretty much take that ERB file and compile it to HTML or JSON or whatever. It's taking Ruby and converting it to you so it can be served to a browser. So we can build it with docker build dot. Don't get too caught up in this. This is just kind of an example. You can see this image is fairly large. So, you know, Rails is pretty big. And there are some techniques to bring this down as well. For instance, I brought up that build essentials. Once you've compiled, you don't really need those libraries anymore. You can get rid of them. But to keep it simple, yeah. So you can see that I'm running this image right here. I run it in production mode because that's what I precompiled the assets for, and everything's working. So, a lot's come out of my mouth right now. I just want to make sure, are there any questions so far with what I've talked about? Awesome. So let's talk about Elastic Beanstalk then. Has anyone here, does anyone use Elastic Beanstalk in the audience? Okay, so this is going to be new to most of you. So we are definitely an AWS shop at Deseret Book. You can thank Jeff Chang up there in the corner for that. He pushes AWS quite a bit. So essentially, Elastic Beanstalk is a way to orchestrate our web services. We saw that diagram before. It takes care of all of that, the application load balancer, the EC2 instances, and it scales for us. And we can choose how to scale as well. So if we want to scale by CPU, or if we want to scale by network in or network out, we can set that very easily by just clicking or setting a value of how we want to scale. So this is great for us because at Deseret Book, we like to be lazy, but not in the negative sense. We want to make sure that we're not working on a weekend or on a holiday. And there's often times where there are big events that happen for our company on weekends or holidays that we know we're going to receive a huge hit from traffic. So the nice thing about the switch to Elastic Beanstalk is we have not had to worry about any going down for the most part. There's also health checks. So this is nice because, as I said before, bugs do make it into our code, and some of them can be very bad. So with these health checks, what Elastic Beanstalk will do is it can sense that an instance is unhealthy, or maybe it's receiving too many 500s, and it will pull that instance out, and it will either roll back to a later version, an earlier version, what I mean by that, or it will spin up a new instance, or let's say the instance itself was just unhealthy. Maybe it ran out of memory and it needed to be rebooted or something. It's also very configurable, so we can choose what type of instance we want. So if we need a smaller instance, we can set that so it's only using small servers, or if we need more memory and more CPU, then we can also upgrade to larger instances as well. The biggest thing about it is you're not paying for the tool. It's doing all of this for you. All you're paying for are your AWS resources. So if you're only using one AWS EC2 instance, that is the only thing you're paying for. I wanted to go over these terms real quick. This is kind of what makes up Elastic Beanstalk. You have your application. That's pretty straightforward. Each application has at least one environment. So usually this is typically going to be like development, staging, production, or maybe review if you do review apps. And then there's something called an application version. This is a lot like a git commit where it just versions your deployment so it knows where to, if it does need to roll back or if you need to roll back manually or go forward. That's what that takes care of. And every application version is attached to what's called a source package. This source package is essentially just a zip file that contains your code or any configuration you have for Elastic Beanstalk. This is an example, a real-world example from one of our projects. If you go to the AWS console and look at Elastic Beanstalk, this is one of our applications running. It's got two environments. There's a development and a production one. If you look at the running version, you can actually see the actual version right there. Don't get too caught up in that. You label that yourself. It just needs to be unique. The nice thing about it is you can look at it. Green means healthy, yellow means it's not doing so well, and red means something bad has happened. So when you look at it, you can kind of tell from the outside, oh, what is going on here, and immediately go check out your environment if you don't have any alerts set up or anything like that. As I mentioned before, application versions, you can view them. Here's another example of that page, and we have these labels. This label does have to be unique. The way we've done it is we just call it project name, the branch, as well, and then the commit SHA right after it, so it ensures uniqueness, and we can kind of trace that package back to a git commit. So when we look at a deployment and why it's doing bad, then we can be like, okay, this deployment is attached to this commit right here. Let's look at what's going on. And I guess I should mention as well, these source packages, they just get uploaded to S3, and Elastic Beanstalk will just pull from that and deploy it. And I'll talk about a little bit more about that a little bit later. But for now, I kind of just wanted to do a little example of creating an application in Elastic Beanstalk, just so you can kind of get a feel for it. So I go in, I create it, I'm going to give it a name. I just call it e-commerce store. You don't have to give it a description. I went ahead and did that. And then I go and click create, and what you'll see is an application with no environments. So I need to go and create an environment. So I choose web server environment because I'm going to be doing a web application. And I'm just going to change that env to production. So this is going to be my production environment. And then you can choose a platform. So I'm choosing multi, because we're talking about Docker. I'm choosing a multi-container Docker environment. But there are many others that you can choose from, like Node, Python, and so forth. And for now, I'm just going to use sample application. And I'm going to configure some more options before I actually create the environment. The first being, I want to choose my instance type. I'm going to switch from a micro to a medium instance. Just real basic. And then I want to auto scale. So I want to make sure that when I do get traffic, I scale up. So I also put a load balancer in front. And I set how many, my max and minimum instances that I should have. And then you can also choose how you want to scale. So again, it can be CPU, network, whatever you choose. So I'll go ahead and save that. And then next I want to create a database so that my instances can connect to a database, obviously. So I'm going to make it Postgres. What happens when I do create this is Elastic Beanstalk does automatically provide environment variables in order to connect. But essentially giving a username and password, click save. And last of all, I'm going to set some environment variables for my default, and it's just going to be my Rails master key. So this is kind of a very basic setup in a nutshell. Click save, and I can actually go in, and now I want to create my environment. It's going to put all of this together, create the database, spin up the instances, create an auto-scaling group. It handles all of that. It can take about 10 minutes. Luckily, I split that out so you guys didn't have to wait. And you'll see a page that gives you your health, and you can see that's okay. You can also see the events, and there's a button to upload and deploy your actual code when you want to. And we can see our sample application right here. So, again, what does this kind of, what just happened here? So I want to reemphasize kind of what we did. Again, a bird's eye view. What we did was we created a web service with a load balancer in front and one or more EC2 instances that we can scale to with the Postgres database. So now how do we deploy our code? So again, we've got this multi-container environment where we have, in this example, a Rails application container and an Nginx container running. So this is where I kind of want to talk about that source package a little bit more. So because we're running a containerized environment, there's an important file called the dockerrun.aws.json, kind of a tongue twister. So this is very important. It is, if you're familiar with Docker Compose, it is essentially the AWS's flavor of Docker Compose, and it's telling AWS how to organize that environment. So back to the IKEA thing, it is essentially your partner telling you this is where the couch goes, this is where the table goes, and don't question me on it. So that's the best way to explain it right there. I wouldn't get too mixed up with some of these files. We've got my Nginx config zipped up in there as well. That's just, I'm going to mount that onto the Nginx container just so Nginx knows how to operate. And this .eb extensions, don't worry too much about that either. This is where you can put some scripts that you want to run pre or post deployment, as well as you can also kind of add any variables or anything like that in that file. It's essentially just any extensions. You can put migrations in there if you wanted to run migrations every time. So this file gets uploaded to S3, and an application version gets created to point to that file, and then you can go into Elastic Beanstalk and say, hey, upgrade to this version right here. And Elastic Beanstalk will take that version and that package, and it extracts it onto a new EC2 instance and spins up new EC2 instances for you. So let's talk a little bit about this. Again, we've got an architecture that looks like this. So what we're going to do is What that file really does is it defines an image. So well, essentially, you define containers, and every container is going to be attached to an image. You can specify mount points. That just says which volumes you want to mount. We talked about volumes a little bit. It's a file or directory that you can mount onto the container. So I actually do this for our Puma socket file. I will mount it onto the host, and the host then mounts it onto the Nginx container, and that's how Nginx communicates with our Rails application. There's also another noteworthy thing here, authentication. So sometimes we do have private images that are kind of behind a password protected wall. There is a way to define what you do. You can look it up on Docker on the exact format of the file, but you can upload it to S3, and it has where your registry is located, your username or password. And in the Docker run.aws.json, you just define where what bucket is in S3, and the key to where that file is, so like the file name or directory. So we've made it past another hump. Any questions about anything I've talked about so far? Yeah.
So, am I correct in thinking that Elastic Beanstalk is more of a competitor to Kubernetes than like a complement to it?
That's hard. A little bit. So AWS does this all the time too. They've got services that like overlap quite a bit, and like they're different in different ways. That is kind of Kubernetes, because AWS does offer Kubernetes. Elastic Beanstalk is a little bit similar. It's using, what do they call it? EKR, Elastic Container Registry, or ECR. It uses that quite a bit, and it uses their tasks. I can't remember the terminology for it. But they are different, but they are similar at the same time. I wouldn't say it's a competitor. I would say, I would call it more like they're different enough to say like, this is good in this situation, this is good for us in this situation.
I would compare Elastic Beanstalk is the closest comparison you may know would be for Root. It's like an AWS trying to take for Root, that's how Elastic Beanstalk became.
Yeah. I would say there's a little less hands-on stuff. I'm not really familiar with Kubernetes, but I feel like there is a lot of hands-on stuff still that goes on. Elastic Beanstalk is a very simple way to just say, hey, deploy this. Yeah. Anyone else?
Probably don't need Kubernetes. It's just passion, and just don't bother with Kubernetes. Use your solution better, like Elastic Container Store or Beanstalk, and just don't do it because your friends are doing it or you know somebody who's using Kubernetes. Because you don't just.
It would never be the same thing, Daniel.
What's that?
He said it wouldn't be the same without you.
Yeah, I would say definitely stick with what you're comfortable with as well, because if something does go bad in your DevOps, you're going to have a hard time if you don't really understand the tool you're using. Okay, is anyone else? Okay, sweet. So let's go back to our CI. This is the example pipeline that we have here. I'm going to kind of go through a little bit real quickly about GitLab CI, because that's what we use. Again, this will transfer over to Circle CI or whatever CI tool, the ideas at least. So yeah, there's something called the GitLab CI.yaml. This is just your config on how you define everything. Again, it sits in the root of your project, and that's where you define the jobs and what stages to run those jobs in. So here's a basic starter file. I define stages: build, test, release, deploy. It goes in that order. And I just say for every job I want to use this Ruby image, I want Ruby already installed. That can be overridden at the job level. I create an RSpec job. You can call this whatever you want. I won't get into the technicalities of this. I just want to point out that I set the stage to test, so this will run in our testing stage. I can call that RSpec whatever, my tests. It's just the way to name what you want to call it. And I actually, I run RSpec, and then next to that, I've got another job that runs in the testing stage, which is Rubocop, and that will lint our code and do some kind of syntax checking as well. You put it all together, looks like this. And when you look at it in GitLab CI, you now have something that looks like this. So the next thing we need to do is we want to build our container. GitLab does make this very easy in that they have their own registry, so there are some environment variables already provided to you. What I do is I log into the registry, I build our container with that Dockerfile that we went through earlier, and then I push that container. So on this, it says latest. I actually wouldn't recommend that. This was just kind of for ease. What we do is we actually will tag it with commit SHA. That's just preference. You can do it whatever you want. The problem with latest is if you build a new container and your Elastic Beanstalk, for instance, is pulling a container, you might get a new container that you didn't want in your production environment before you really wanted it to go to production. So stuff to think about. When you look at it in GitLab CI, you now have something that looks like this. You got your build, you got your testing stage. So now we want to release. So the reason I split up release and deploy is because there are these kind of two separate jobs where you are uploading your code, but you're not exactly deploying it. You are just creating a pointer to where Elastic Beanstalk can use that to say, hey, I want this code. I'm going to move to it now. So I called it release, and this is the part where we're actually uploading our code to S3, and I use the AWS CLI to just create an application version. Again, it's just a pointer to our code or source package. And I give it a version label, which again is like, I use project name, branch, and SHA. So once that's been done, we can then, if we look at back to our application versions page, you'll see something that appears here. And I also forgot to mention, you can see this deployed to. You can actually have the same application version deployed to this two different environments. So some people use this in certain kind of deployment strategies where they want to use the same version, and then what they'll do is instead of deploying, or what they'll do is they'll swap environments, if that makes sense. So like, let's say I had, they call it red, is it red, green, red, blue? Blue, green, thank you. So that's a strategy you can use. So what we want to do now is we want to actually deploy it. So we've created our application version, we've got our source code up there. Now we actually need to tell Elastic Beanstalk, okay, move this, create new instances with this version, test them out, and then roll forward if everything looks good. So that's essentially what it's doing. You choose the environment you want to update. So that's what that does. It's essentially in the console. If you were to select a version here and select deploy and choose an environment, that's what it looks like in the console. And then if we look at our GitLab dashboard, this is what our pipeline now looks like, where we have these 4 stages. The nice thing about this is we can retry each of them if anyone fails. We don't have to, we've got it separated out where we don't have a huge mess like we did when we started. I know this is a lot to take in, so are there any other questions and cat tax? Yeah.
What's your push to production timeline? Like how, you push a code right now, how long until you can see that on the inside of a manager?
So this kind of depends. And it also kind of depends how you label it as well. So for the CI, it takes 30 minutes. That is just from the point to where we call update environment. However, for the actual environment to roll through and update, so there's different deployment strategies. What we do is we'll put in a few instances, it will test them out. If they look good, then it will put in the rest of the instances and pull out the old instances. That can take some time, that part right there, and sometimes it does fail, but it will automatically roll back for us. That part, depending on how many instances, it can take probably, on average, it's probably about 60 minutes. Yeah.
How much of it is your container build time?
Our container build time is probably about 8 minutes. It's honestly, it's something we can definitely optimize. Rails itself is pretty bulky. But yeah, 8 minutes is typically, and a lot of that is actually due because we have some large libraries we need as well. So for instance, we need to connect to SQL Server, so there's some third-party libraries that we have to include in our container. And
I think you probably cut that down to the multi-stage build.
yeah, no, definitely. And if we layered our Docker images, that's, yeah, you're definitely right.
What about your test suite runtime?
Test suite runtime is, that's probably about 20 minutes. It's not, well, yeah, I'd say 15 to 20 minutes. And what we actually do is, I know up there it shows a single RSpec job. But what happens in our e-commerce stores, that will split into 5 different jobs and take a section of the test suite and run it in parallel.
I was gonna say, like, what you've done is great, and I just offer just a different pathway, and that
Oh, that'd be great, yeah.
all this running, but all self-contained maintenance, the whole CI/CD, everything, and it's all built using Terraform and deploying to ECS Fargate, so it's completely serverless. So if anybody's interested in that solution, it's just a different solution. It's not better or worse.
Yeah, I think we've discussed that one actually in kind of like the matter is just the time. Like
If anybody's interested in that, I'd be happy to show you what that looks like. It's using AWS code build and code pipeline, and it's all native to Amazon. Awesome. Which I think has some benefits. GitLab's great.
yeah, awesome. Anyone else? Yeah.
So in that continuous deployment process, is there a section or something you guys block out for like an annual QA process, or you just really have to look on your test code?
So we've kind of discussed this a little bit, where we would do a review apps type thing, and what would happen is you can actually set it up so you have to manually go in and say, okay, continue, and it will tear down the review app environment when it's done. And essentially it's just all code review right now. Our QA person, she's here right now, and what we'll also do is when we have a merge request, we assign it to her, and she'll go in and QA it and then actually merge it where it gets merged to master. Awesome, I think that's it. All right, thank you guys.